Now see a nuclear force. You know, we have done already electrostatic force, and in electrostatic force that is called actually Coulombic force. In Coulombic force I have seen here, if there is a positive nucleus at the center, electrons revolve around it. And you know, when these electrons revolve around it, they have got binding energy. But if you look at the nucleus, we have seen the graph binding energy per nucleon with the mass number. In that graph I have seen binding energy per nucleon is very high for iron, and the binding energy of the nucleon is higher than the binding energy of the electrons. Obviously, the force acting inside the nucleus is much stronger than the electrostatic force or the Coulombic force acting between the nucleus and electrons. So here we are going to discuss here the concept of the nuclear force. In nuclear force, actually this is the force which acts between two nucleons, that can be between the proton and proton, neutron and neutron, and neutron and proton. Inside nucleus these three combinations are possible. So the force acting between these nucleons is known as nuclear force. But see here, nuclear force is much stronger than the electrostatic force. It dominates electrostatic force inside the nucleus, and because of its strongest nature, nucleons have got the binding energy much larger. And also here the nuclear force is a short range force. It acts only for the small distances. It means the nuclear distances. If you increase the distances, the nuclear force reduces, and now electrostatic force dominates. So inside the nucleus, the force acting, which is the strongest force in nature, is known as nuclear force. Its properties are there. First one you can write, it is strongest force. It is strongest force. It is a short range force. It means it acts only for the small distances here, and also it does not obey inverse square law. So it does not obey inverse square law. As you know, the gravitational force and the electrostatic force does. So it does not obey inverse square law, and also in these cases nuclear force also here it is independent of the charge. So we can draw the graph for the variation of nuclear force with the distances. So if you are taking here like this, first I am showing here the potential energy, that is in mega electron volt, and the graph is something like that. There is R over here. This is your point, suppose 1, 2 and 3, and this point is around here known as 0.8 Fermi, and this we can take 100 and this we can take here minus 100. So at this point here it has the negative value maximum. So the electrostatic, this nuclear force is attractive up to this. So this side nuclear force is attractive and this side it becomes repulsive. So this is about the nuclear force. But see what is the cause of the nuclear force? Cause of the nuclear force is actually exchanging of the particle between the nucleons. These particles which are exchanged between the nucleons are known as mesons, like a pi plus meson, pi minus and pi 0. So these are the mesons particle which are exchanged between the nucleons. Because of that nuclear force comes into action.